So you're going to see some problems in the homework where you're supposed to sketch the graph of the derivative given the graph of f of x. So the operative word here is sketch. At this point you don't know exactly the nuances and details of the graph. But what you can do is look at the given graph and notice where it's changing. Notice the important parts of it. So where it has a horizontal asymptote, you know that its graph is approaching a horizontal line, so the tangents are approaching 0. So you know that as for these parts where the graph is going to the horizontal asymptote, the derivative function is going to be near 0. Here on this interval, as it's approaching the y-axis, the graph is increasing. So that means the slopes of tangents are positive. So the derivative is going to be above the x-axis. And likewise, where it's decreasing, the derivative is going to be below the x-axis. Now at this max, local max, the tangent line is horizontal, so it has a 0 slope. So at this point, the derivative is going to have to be 0. So let's trace out on these different intervals. So notice that, like I said before, the derivative is going to be 0 where this original graph is approaching a horizontal line. And then as the graph is increasing, derivative is getting more positive. So at about this point, it really starts picking up, right? So what's happening on the original curve here is it's increasing and it's getting steeper, right? It's increasing at an increasing rate. So at some point, it kind of changes how it's increasing because it's going to a maximum and then it's changing again. So you can see where it's increasing and continuing to get steeper, the derivative is going to be positive and increasing. But at some point, the derivative has to change direction because the graph is approaching this horizontal tangent line at the maximum. So somewhere around minus 0.5, our original graph starts to flatten out because it's approaching this turning point. So that is where the derivative is going to have to go from increasing to decreasing because it's got to make its way back down to the x-axis in time to get there to coincide with this local max on the original function. So if we keep moving this, we see that the derivative goes back down to 0 at the local max. Then when f is decreasing, the derivative is negative because it's the rate of change. And then the original function starts to level out as it's approaching that horizontal asymptote. So our derivative is going to have to change direction again to level out because it also is approaching 0. And this is what the graph of the derivative of this function looks like. So again, you're expected to do a sketch, not to have something perfect, because we won't discuss curvature and concavity for a little later, and those are some characteristics that will help you better graph the function. The big takeaways are where f is increasing, the derivative is positive. Where f is decreasing, the derivative is negative. Where f has a max or min, the derivative is 0. And just you're going to have to remember this derivative is going to be changing as the steepness of the original curve changes. So you'll also be asked questions about interpreting the derivative function in context. So here's a graph of a population of yeast cells in a lab. So the horizontal axis is over time. P is the population or the number of yeast cells. So you started with about 5, 6, whatever yeast cells. And then notice that the curve starts out increasing rapidly. It's increasing at an increasing rate because it's going to continue to increase until it gets about here. And here it's still increasing, but notice its rate of increase has to be slowing down because it's approaching this horizontal asymptote up here. So again, let's look at the graph over different intervals. So from 0 to 5, our function's increasing, which means our derivative's positive. And since it's increasing at an increasing rate, the values of the derivative are increasing. Between 5 and 10, our graph's still increasing, but it's slowing down in its increase because it's going to have to make this turn to go to this horizontal asymptote. So our values of the derivative are still greater than 0, but they're getting smaller. And then from 10 to infinity, thereabouts, it looks like this function has reached its horizontal asymptote. So that means that our derivative is going to have to be going to 0 as well, because horizontal line has a 0 slope. So our derivative is always positive because this thing is increasing. It reaches its maximum at about the point on this curve where it decides it's going to have to slow down in its rate of increase. And then the derivative is decreasing where this is increasing at a decreasing rate. So whenever you hear the term for a function is doing something at an increasing or decreasing rate, you can just switch that rate with derivative. The derivative's increasing or the derivative's decreasing.